Mars is the place that most of our spacecraft, landers, and rovers are studying, searching for any evidence that life ever existed somewhere else in the solar system. But talk to planetary scientists and they're just as excited about the ocean worlds of the solar system. The moons, asteroids, dwarf planets, and Kuiper Belt objects where there could be vast oceans of liquid water under thick shells of ice. Perfect environment for life to thrive. We've only had tantalizing hints that these oceans are there, but NASA is building a spacecraft that will study one of these worlds in detail, the Europa Clipper. And they're not the only ones. The European Space Agency is building their own mission, the Jupiter Icy Moons Explorer. Astronomers have known about Europa and the rest of the large moons of Jupiter since they were discovered by Galileo in 1610. But it was in the 1960s that ground-based telescopes from Earth started to study the moons with enough detail to realize they contained large amounts of water ice. NASA's Pioneer 10 and 11 flew past Europa in 1970, confirming its icy exterior. But it was really the twin Voyager spacecraft that gave us our best view, revealing features on the moon as small as about 2 kilometers per pixel. Their images showed how the surface of Europa is bright and icy, covered with bizarre stripes that look like cracked ice. And unlike other worlds in the solar system, Europa had very few impact craters, which meant that it was being constantly resurfaced by fresh material, like a space Zamboni. The Galileo spacecraft arrived in the Jovian system in the 1990s, bringing an orbiter that would remain in the area, studying Jupiter and its moons in tremendous detail. Over the course of its mission to Jupiter, Galileo made 12 separate flybys of Europa. Observations from Galileo helped planetary scientists calculate that the subsurface ocean on Europa probably had more water than Earth. Galileo's cameras revealed huge sheets of ice that broke apart, with fresh water welling up to fill in the gaps. Clearly, this is still an active world. The activity comes from the tidal interactions with Jupiter, similar to the tides that we have on Earth with the Moon, except on a dramatically larger scale. They cause Europa to flex back and forth during its orbit, increasing the amount of heat inside. We can see the dramatic effect of this tidal flexing with Jupiter's closest moon, Io, which is the most volcanically active place in the solar system. Europa could have volcanism too, down deep beneath the ocean, providing energy and the raw material that could help life thrive. To study Europa up close, to answer these questions, NASA is building an orbiter, and maybe even a lander, and it's called the Europa Clipper. The name comes from the old clipper ships that used to sail the oceans in the 19th century. These were 3-masted ships that moved tea and other goods across the Atlantic Ocean. And like these ships, the Europa Clipper will sail past Europa every 2 weeks or so, scanning its icy surface and searching for evidence that Europa could have all the raw ingredients for life: liquid water, energy, and chemicals. Although its destination is Europa, it won't remain in orbit that close to Jupiter's powerful radiation belts. Instead, it'll make a long orbit around Jupiter that brings it back every few weeks, so it only has to spend a short period of time in the radiation zone. Mission planners have largely settled on the instrument package that the Europa Clipper will carry on board. Of course, there will be the high-resolution camera to provide images of the surface of Europa with 100 times more clarity than the best images taken by the Voyagers. It will map out most of Europa to a resolution of 50 meters across. It will also have a plasma instrument and magnetometer to measure the magnetic field around Europa in more detail. A mapping imaging spectrometer to map out the organic chemicals, salts, and other material in the interior of Europa. A thermal emission imaging system to sense any changes in temperature across the surface of Europa, locating warmer places where liquid water could be upwelling from beneath the surface. A mass spectrometer to determine the composition of the surface chemicals. An ultraviolet spectrograph to map out any water plumes that could be ejecting out from the surface of Europa and into space. a dust mass analyzer to see small, solid particles ejected from Europa. And most excitingly, a ground-penetrating radar that could peer down through the ice on Europa to map out the thickness of its icy shell and subsurface ocean. It could help discover pockets of water closer to the surface, which might be an ideal place for future missions. The Europa Clipper is expected to be launched on NASA's Space Launch System, which is still under construction as I'm recording this video in 2019. SLS has a few missions to launch for the Artemis program, but it's expected to launch the Europa Clipper in 2023. This is the ideal launch vehicle, since it would be able to send the spacecraft on a direct trajectory which would take it to the orbit of Jupiter in just 3 years. But if the SLS isn't available for some reason, then it could also launch on a Falcon Heavy or Delta IV Heavy. Instead of a direct flight, they need to make a few gravitational flybys of Earth and Venus to make the journey. In fact, according to some estimates, by switching to a Falcon Heavy, NASA could save enough money to send a similar mission to Saturn's icy moon Enceladus as well. And who knows, the SpaceX Starship could be flying by then, and it would make the ideal launch vehicle. In preparation for this mission, planetary scientists have been scanning data from older missions, and they've found something very exciting. There appear to be plumes of material blasting into space from Europa, similar to the ice volcanoes that Cassini found on Saturn's moon Enceladus. In 2012, ultraviolet images from the Hubble Space Telescope hinted that there were plumes on Europa, but the data was inconclusive. Planetary scientists realized that Galileo made a flyby of the exact same region in 1997, and it had recorded data about Europa's magnetic field. Cassini had helped astronomers realize that icy plumes cause a characteristic blip in the magnetic field. It turns out Galileo had flown right through the plume and recorded the event as a bend in the magnetic field in the region. When the Europa Clipper arrives, it'll make a series of low-altitude flybys of the region, but this time, scientists will be ready, and they'll know what to look for. The spacecraft will be equipped with instruments that will be able to sample the frozen liquid and dust particles thrown into space. It's the next best thing to actually being able to sample the ocean directly. Nothing's decided yet, but US Congress has been advocating for a lander to come along on the mission, touching down on the surface and sampling the world up close. This is actually a controversial decision because it doesn't entirely make sense to send in a lander without having a detailed map of the surface of Europa. If you only get one shot at landing on Europa, it makes sense to map out the world in great detail first. Then, choose a landing site and send a follow-up mission to explore interesting regions. But Congress actually awarded NASA $195 million in 2019 for the development of a Europa lander, and earmarked future spending as well. And this isn't a mission that was requested by NASA, but driven by Congress. Of course, landings are exciting to the public, and it could help drive enthusiasm for the mission and space exploration in general. If a lander does make it down to the surface of Europa, it could actually face very difficult terrain. A new study calculated that the surface of Europa might be the perfect conditions for creating penitentes. These are tall, jagged blades of ice that form when water sublimates, going directly from ice to gas. And they're found in the high-altitude regions in the tropics of Earth, like the Andes Mountains. And in the lower gravity of Europa, they could grow 15 meters tall, triple the height of Earth. Any lander would need to be able to sense and navigate around these ice spears without any real-time assistance from Earth. Although Europa Clipper has only been in the works for a few years, it's not the only mission going to Europa. Europe's got a mission in development too, and we'll get to that in a second, but first I'd like to thank Dennis Beimelt, Eric Bogatin, Christian Ulving, Nikolai Benson, and the rest of our 803 patrons for their generous support. They contribute so that you can see these videos and we can make them freely available to anyone who wants to learn about space. Join our community at patreon.com/universetoday and get in on the action. When it comes to Europa, NASA isn't the only game in town. The European Space Agency is working on their own mission to Europa, the Jupiter Icy Moons Explorer, or JUICE. This is the first large-class mission of ESA's Cosmic Vision program. Unlike the Europa Clipper, JUICE will spend 3 years studying Ganymede, Europa, and Callisto, all 3 of which are thought to contain a subsurface ocean. By studying all 3 of these worlds in turn, it'll provide a comparison between them, helping planetary scientists figure out what conditions are best for life. As with Europa Clipper, JUICE will have a suite of science instruments on board, which will help it map out the surfaces of the 3 moons, as well as get a glimpse of their icy interiors and subsurface oceans. It'll map out Ganymede's magnetic field, the only moon in the solar system known to have one, which is thought to be caused by a rotating core of liquid metal. It's strong enough to create auras in the sky above Ganymede, even though it's embedded inside Jupiter's enormous magnetosphere. For Europa, it'll help in the search for chemicals of life, organic materials that could be on the surface, tenuous atmosphere, and welling up from inside. And JUICE will be equipped with a radar system that will measure the depth of its subsurface oceans. If all goes well, JUICE will launch in the mid-2022, ahead of Europa Clipper, on board an Ariane 5 or Ariane 64 launch vehicle. It'll take 7.5 years to get to Jupiter, making flybys of Earth, Venus, and Mars, and arriving in 2029. We're going to Europa. As early as 2022, 2 missions could be blasting off to study the icy moons of Jupiter, arriving before the end of the decade to study them up close. One of the best places in the solar system to search for life. And we're just a few years away from a spacecraft's arrival, maybe even multiple orbiters and even a lander. It's a pretty exciting time in space exploration. What do you think? Do you think Europa is a priority to explore? Does it make sense for both the US and Europe to send missions at the same time? What about a lander? Let me know your thoughts in the comments. Once a week, I gather up all my space news into a single email newsletter and send it out. It's got pictures, brief highlights about the story, and links so you can find out more. Go to universetoday.com/newsletter to sign up. And did you know that all of my videos are also available in a handy audio podcast format, so you can have the latest episodes as well as bonus material like interviews with me show up right on your audio device? Go to universetoday.com/audio or search for Universe Today on iTunes, Spotify, or wherever you get your podcasts, and I'll put a link in the show notes. And finally, here's a playlist all about the exploration of Europa.